5, 4, 3, 2, 1. Hello, everyone. Welcome back to the Uncle Gold podcast. My name is Borna. This is the first show that we're doing this year in 2022. And of course, we have Brendan Caulfield back on the show with us. Brendan, welcome back to the podcast.
Hey, thank you very much. It's very good to be back. First podcast 2022. Wow. I'm honored to be invited aboard for this one.
Me too. I'm super excited to start off the year in a good spirit. And as the year kind of starts, everyone's thinking of building out their ideas and goals and setting up their life. And we're going to dive into a topic today that's kind of also focused on building and creating. I think it'll be super interesting for people who are maybe not familiar with the topic. I don't know that much about it, so I'm looking forward to hearing some firsthand experiences from yourself. So the big topic for today is 3D printing. So as I've gathered, you got involved in 3D printers in the last year, been studying them for a while now, looking into the technology and all of that. But maybe for people who are not that familiar with the topic, can you give us a little intro on what is 3D printing, how does it work, and just general insight?
At its simplest, just as the printer behind me there starts to kick off, 3D printing is simply taking a three-dimensional file from your computer and building that in the real world. And there are several different ways of doing that. But the idea is that instead of needing to go through all of the kind of traditional manufacturing processes to bring a product into reality, to take it from your imagination into the real world, which has traditionally been a very expensive process and very time consuming, and something that people need to have a lot of specialist knowledge to accomplish. This cuts all of that down to basically having the ability to build it in the computer and then pressing the print button, and then it gets assembled. The specific way that a printer will work varies depending on what type of printer you have, but the most common type is what I have here. Because I have two of them and the image is flipped. So this is a what's called a filament deposition modeling printer. I'm not sure why it's printing where it's printing. I'll have to have a look at what that file is all about. But anyway, filament deposition modeling, it's fancy words. It just means it takes this spool of material here, this plastic spool on top, takes a line off it almost like a fishing line, runs it down into a heated nozzle which melts the plastic, and then the head moves around and draws a two-dimensional shape. And that shape is determined by the 3D model that you would have created on the computer or downloaded from the internet, which is another very easy way to make things with a 3D printer. And it looks at that model and then slices it into two-dimensional drawings. And when those drawings are all stacked on top of each other, you get the 3D shape of the object. And so that's how it builds it in the real world. It draws the melted plastic into those shapes and stacks them. And it can be slow. Oh, I realize now what it's doing. It can be slow and methodical, but it is so satisfying to dream up something or create it in software and then see it made real, and to see it emerging from like Michelangelo's David out of the block of marble, to see this spool of plastic become the item that you've created. For example, I'm a big Star Trek fan, and I created this ship, designed it over the course of the last year or so, and I created it out of multiple parts so that I could add electronics to it and have it light up and stuff. So it's not painted and finished yet, and I'm actually making a number of changes to the model files. This is more of a Pathfinder prototype than anything else, but the point is that like this is a large solid object that I have put batteries into. I put wiring through it. I've come up with all sorts of little mechanical ways that it can connect together. There's lots of like problem solving thinking that you go through to like create these objects. So for someone with an interest in science and technology with a creative streak and who enjoys problem solving, I think it's a really rewarding discipline to get into, if that's the right word. Interest anyway. And it can be a hobby, but it can also be a living. It can be something that will earn you your keep.
Awesome. I love the idea that you can create something out of nothing just from your ideas, and using kind of like designing the models on the computer and then bringing them to life, as you said. It's really cool. One of the things that we were discussing before the podcast was basically that this whole 3D printing discipline was expected to be a huge boom. Everyone was making a huge fuss about it, like, oh, everyone's going to have a 3D printer at home. Can you tell us a little bit why it didn't take off as people anticipated it would, and what's the situation with that? Because I personally think it's a really cool technology.
It is a really cool technology, and it's a very capable technology. But I think one of the reasons that it didn't take off quite the way it was expected to is because it was a bit overhyped. In particular, people called it, and even brand names were named after the replicator from Star Trek, which is like this hole in the wall that people walk up to and say, I want a steak sandwich, and it goes, and there it is. And so in concept, it's not a million miles away from that idea. However, instead of it taking 5 seconds to materialize, it might take 5 days to materialize. And that's, I think, the big bugbear. And that's why you hear about so many people who've got a 3D printer and they're all excited about it, and then you really don't hear about it after that. It's because it's a slow manufacturing process. It's not a magic wand that just creates things. Except it is. It just takes time. And there's that kind of letdown of, oh, this is going to take a day and a half to print this small object. But if you have patience with it, it's so rewarding. There's also, it's a technology that's very much in its infancy. So like, there are obvious optimizations. I don't know if obvious is the right word there, but optimizations that are very apparent in the 3D printing circles that can be made to it that just haven't hit the market yet. So there are things that, but again, all of these things will marginally speed it up. So you're looking at, a day instead of a day and a half. But you're still making large time investments. They can be noisy. I don't know if you can hear this one running in the background. The sound suppression might be killing it.
No,
but,
it sounds very silent, actually. Like, I can't hear any noise.
Okay, well, it's going, and there's like whirring of motors. When you first see it in operation, it's so cool because it's like having a piece of a like an automobile assembly line robot working in your living room, and I just love that. I still get a kick out of seeing it just trundling away and printing. But it can be noisy. There can be odors from the material that it's melting, but they're not super strong. I don't think they're very objectionable. It depends on what filament you get as well. And I should say as well, when we were breaking down what 3D printing is, as I said, this is probably the most common type, which is melting a spool of solid plastic to make it pliable and drawing out the shapes of it. But there are other types. There's resin 3D printers, which are basically a bath of a resin mix that is a UV activated resin. And then they have what amounts to basically a computer monitor built into the bottom of the bath. And it has UV pixels. And so it flashes up the shape of the layer that you want to print at that particular moment using UV light, and that cures the resin in that shape. And then the print bed actually lifts that layer up a bit and it flashes up the next layer. And so it does that. Those can be a little bit faster than these printers. They can be a little bit more, a little bit smoother. If you look at this print, I don't know if it'll come up on camera, but up close, you can sort of see layer lines on that, because this was printed sort of standing up. And so you get that kind of texture on things. that can be undesirable. You can deal with it with coatings and whatever, but with a resin 3D printer, those layer lines tend to be far less apparent. But conversely, small detail on the resin 3D printers can be a little bit muted because of that, that smoothness. The main issue with the resin 3D printers, well, there's two. One is that they are generally quite a small print volume. And the other one is that you're dealing with liquids, and toxic liquids at that. And there can be some pretty stinky fumes, and they're not great to hang around. So you kind of need a dedicated print room if you're running a resin 3D printer, and you also need to be willing to deal with spills and mess and that. I don't know where they come in terms of expensive materials, but the printers themselves are generally more expensive than the FDM printers. And that would be generally because you're dealing with a display technology. You're essentially buying a monitor with a bunch of robotics attached to it, as opposed to just a heater with some motors.
Yeah.
And then there's other types, like there's a type that uses a tub of powder that it melts with a laser and then rakes over the top. And so it builds the layers that way. Those seem to be very popular among the sort of, can't think of the name of the service, but like public ordering services where you like order a model to be made for you. One thing that they seem to be very efficient or effective at doing is including color in that. I'm not sure exactly how that's accomplished, because with these printers you're dealing with the color. Like obviously this is all one color, because that is the color of the filament it was printed in. Now, it is possible with some heavy modification and a lot of hassle to mix colors as you're printing. It's not something I've experimented with, and it's probably a path for improvement further down the line to make them more appealing to home users and so on. Just have a few different lines of filament going in of different colors, and you can mix and match as you need to. But yeah, that's still an area for development.
Okay.
Incidentally, the top layer of that may look different because I did paint that with some initial base coats. But anyway, so yeah, there's those few options available. But in terms of bang for your buck, these guys are very affordable. I actually got into 3D printing because my brother pointed out that there was a deal, I don't know, it was deal of the week or deal of the day on one of these websites with I think it was 180 euros for one of these. And that's actually since then the actual regular retail price has dropped to around that price now. So you can get one of these for 180. And I mean, this I think speaks for itself. This is if you know Star Trek, this ship is quite recognizable. And I built the model for this myself, so I was very exacting in my attention to detail on it. And I am super pleased with how that came out. Even with those visible layer lines, it just looks great.
Looks very cool.
And it's super solid. Like I can hold it by the front end here, which is actually a piece that slots in. Nice. That I designed to slot in, and there's no worries about that. So you don't, I mean, you can rely on this material for strength to a certain degree. You know, it's not going to make a hammer. But you can, I have used it to print pieces that take mechanical stress inside, like a hair clippers. There's a tiny little sprocket that had broken in the hair clippers. I printed a piece, put it in there, right in the middle of all of the gears and bits and pieces, and the thing works like new now. I've printed quite a number of pieces that take mechanical stress to fix stuff for like people running industrial kitchens and stuff like that. They have a piece that if they have to replace it, they need to buy like a 5,000 euro appliance just to get, because they won't source the part. So if I can reprint the part, then they've saved that money. So I've done that a few times, and that's great. Those are commissions that I've taken as well. So like I am making a little bit of money out of this.
That's kind of how it appealed to me when I was looking at it a while back with a friend. We were thinking of like, oh, should we start a 3D printing business? Buy a bunch of printers and then do kind of just that. Focus on, let's say, one industry that needs a bunch of parts, like I don't know, car mechanics. But we kind of never got into it. We gave up on the idea, but I still think that it's a really great idea to do, because there's a whole bunch of different industries where there's a specific part, and if you can't get it, it's a big problem for your business or whatever you're doing. Yeah. And then, as you said, if you have to buy just that part individually, it's hard to get. It takes a lot of time. It's super expensive, and 3D printing seems like a slick way of solving that problem.
Yeah, and for me personally, like I'm a terrible businessman. I'm never motivated by money. I'm motivated by problem solving and creativity, and I love that aspect of can I take this broken thing and figure out how it should work again. And it's not only a case of matching the shape of the broken part, it's also a case of understanding how the force gets transmitted through it, because if you're laying down print layers and your force is coming from the side, that might just shear the layers off. So you have to think about, how am I going to orient this on the printer to get the force distributed through the part properly? And so there's a lot of that kind of mechanical problem solving thinking that goes on. And also you just get to design stuff. You were talking about my my new job, which I actually got as a result of all of this. I had been talking about my 3D printing work, which I was just doing for my own hobbyist satisfaction. I mean, this is to be a product that I'm planning to sell. It's been to be a product for about a year at this point, but so like things can take time to bring to market, unfortunately. But I've been talking about all of that, and in my friends' WhatsApp groups, and one of my buddies who likes to do a bit of cosplay needed a piece for costume, and he sent me a file, and it was a Star Wars costume, and it was a little piece for like Han Solo's jacket, little grenade detonators that he has in his pocket. And I looked at the file, and I looked at the screen grabs from the film, and I thought, this file is not very accurate. I can do a better job. So I modeled out the piece myself, printed it out and gave it to him. And we were talking afterwards, and he was talking about how he works with this company that does educational outreach on a science, technology, engineering, maths kind of bent, STEAM outreach, and that he thought maybe we could. And I just said, if anything comes up that you think 3D printing might be appropriate for, mention my name. And so we did, and I got contracted to design and print products for them. So
awesome.
Yeah, so I get to like work on the design thinking of these products, which was the part that I enjoyed most about this. This is not the only example I have. I've done a few other products that I kind of put together from scratch, and I will actually take this apart just to show you, because I wanted this to be what's the term, user serviceable. And so most of the time you get these models and they'll be screwed together, or you have to glue them together yourself. But I built in these little sprues here that, I don't know if you can make it out, have a little bit of an S bend on the end. And so they slot into other sprues inside the lower half that have S bends. And then everything just kind of
it clicks together.
Exactly.
Yeah.
And so
awesome.
So that was one of the like little mechanical problem solving elements that I really enjoyed. So that's back together now. And you get to kind of do that. In this case, it was because it was an object I wanted to create, and I wanted to have certain functionality and whatever. But it doesn't matter if it's something you're doing as a passion project because you like the thing, or if it is a practical thing that needs to fulfill certain requirements. There's the same kind of enjoyment and satisfaction from doing that mechanical problem solving. And so I get to do that with the educational kits that we're working on as well. I'm not going to tell you what the nature of this is because I don't want to give away too much IP, if you will.
Okay. Okay.
But so I'm working on this thing that's a kind of a punch. It's supposed to punch holes in paper. And I realized that because I was printing this as a single piece, I was dealing with certain unpredictability in where the pivot point was.
Yeah.
And so now I'm redesigning it as a two-part slot together mechanism. And it will have, I will still use the springiness of the material. That's a good example of the versatility of this material. Like this is printed from the same stuff as that spaceship, but there's rigidity and springiness to it. So you can kind of come up with, what is it they call it? Compliant materials, I think, designs that that work for you and use the material properties. So anyway, I'm getting kind of off or too deep in the reeds here, but it's very rewarding, I think, creatively.
Yeah, yeah. I know. I definitely know the feeling. I kind of get the same feeling. Well, not from that much of a technical side of producing objects with 3D printers, but I get the same feel from creating a YouTube video. You know, you start from an idea. It's nothing there, right? And then you're just like, all right, I'm going to make this, and then you figure out how to do it. You film it, you edit it, you make changes, you go back. Oh, this doesn't work, and then at the end you get like a finished product and not only you but other people can also enjoy it. So I think it's super rewarding on like two parts, because you can also not just sell this to other people, you can show them if somebody comes around to your place, and you can play around with it and even make gifts for people. So it's very versatile, and I really think it's a cool thing. Do you have like a favorite object that you ever printed?
Well, I would say it's almost certainly
this ship.
There's so much of me in this. I mean, the design is something I copied from an existing design in Star Trek, but not to get too nerdy about it, but nobody has ever done this ship justice. It's always been based on flawed reference material. The official models, I have one of them up there, you can just see in the corner of the shot, same ship. But that one, the lines on it are just not right. There was an original studio model, physical model built for the TV show that had a certain look about it, and that was never replicated. Even when they switched to CGI visual effects in the TV show, they just kept getting it wrong. And it worked. It was functional enough for the show, and it was clearly the same ship and whatever, but it was just slightly off. And so that always bugged me. And then all of the merchandise that's ever been made of that ship has always been slightly off because of that. So I wanted to get as much reference together of the original studio model and replicate that as much as I could. And I mentioned that I was like working on the source model for this. So this is a prototype. I realized that there's slight inaccuracies here and there. So I have to, there's no choice. I have to get it right. So that's definitely the passion project and the one that I'm proudest of. However, that's not finished yet, and it has been taking over for too long at this point. I had to shelve it for a while after I got the job initially because my workload just went way up, and I couldn't sit there and then finish work and then work on the same software and the same tools and things. So I just had to shelve it for a little while, which I felt a little guilty about because I love the thing and I love working on it, but I just you know yourself, I just had to stop at that point. What I wanted to produce is not a model kit, but a toy as such. That's why this one lights up, because I wanted it to have, where's that stuck? I'll have to have a look at that. I wanted it to have play features. For example, I'm in the process of wiring up some weapons lighting that will also have sound effects added as well.
Awesome, man. That it looks like a really elaborate toy.
Yeah.
How did you figure out the wiring and the lighting? Did you work on some things like that beforehand, or is it everything just like learned it yourself?
I very much learned it myself. I did some custom work on some other Star Trek toys down through the years, and it's just sort of bungling my way through and figuring out what works and what doesn't work. And a lot of cases, banging my head against the wall going, why isn't this working? Until I figure out, oh, well, the solder didn't melt properly, and so the contact has been lost there, and that kind of thing. But yeah, I mean, this is, I'm missing a microchip actually, but I have a couple of chips in there. I wanted some lights to blink. I've lost some buttons now. I'll have to pick them up. But so yeah, I went sourcing them from the internet and just looking up guides on YouTube as to how to work with them.
Yeah, that's how I would approach it. Like, I think it will take me too much time to figure all that stuff out, and I'll probably go to a bunch of tutorials on everything. Like,
yeah, that's really all there is to it. The internet is such an incredible resource. I mean, not only for learning things, but if you have a 3D printer, you can go to the likes of Thingiverse, or I can't think of the other website names, but just search for like 3D model of whatever you want, and you can generally, among the first results, even if you don't search for a printable model, there will be a printable model available. So many of the items that I have printed for people have just been stuff that they have found on those sites and they needed printed, and so I would just go ahead and do that for them. And indeed, the case that I was talking about, my friend who needed the cosplay item, he found that model on a site purporting to be this item, but when I looked at the model and the reference, there was just too much of a disparity there, and my need for accuracy, the same as I have with the ship, would not allow me to print that item for him without doing a better job on it.
Awesome. Sounds like a really, really great hobby, man. I see that you're really enjoying it and having a lot of fun with it, and I'm glad that you found a job in the same niche. And I can imagine that it's taking a lot of time to get like a design like that in place. What would you estimate for, all right, maybe not for such an elaborate design as the ship, but maybe for smaller, simpler designs, how much time does it take to create one approximately?
Well, it really depends, as you say, on how elaborate it is. But for example, that punch thing, where did I put it? Yeah, that yoke, I came up with the design of that entirely on my own. This is 100% my creation, with the exception of the spacing of the holes, which need to interface with other technology. That I think took me about a day to come up with that design, and then printing it out probably took about 4 or 5 hours. I can't really remember. It's a while since I printed that. So you can rapidly prototype things, and that's the term, rapid prototyping. That is really the main use that 3D printing has been put to in industry applications. It massively reduces the amount of time it takes to get to a production like prototype.
Awesome. Yeah, I can imagine that some engineering teams just 3D print something out just to get a physical feel for something, and then they refine it, and then they create the real product either through traditional terms or just 3D print a better version of it.
This is iteration number 6 of this punch, and it's not the final one, but that's exactly what I'm doing with these, because when it comes to an item that needs to carry out a physical activity like a punch, to punch holes in paper, you need to print it to test. And for example, one of the reasons this one is not the final version is because the punch pieces do not fit through the holes, and that's in part because of that unpredictability of the pivot point I was talking about there. So that's an example of iterative prototyping using 3D printing.
Just to comment on this design, I feel like the dots on the top shouldn't they be sharper to punch through paper?
They should, yeah. And that's another thing that prototyping it physically helps with, because in the case of this item, my manufacturing method is going to be 3D printing. So I need to print it out to check, do my sharply modeled teeth, so to speak, come out sharp? And the answer here is no. So I need to think about, do I reorient this? Is there some modification I need to make to the printer to get it around those corners sharper? And that leads me on to actually another interesting and fun aspect of 3D printing. Not this printer, but the printer on this side. If you look very closely, you probably have to squint. Maybe I'll send you some photos to illustrate the difference here. But the filament is entering this printer in a different location to this one. The filament comes along to the side here. The motor is mounted on an unmoving platform there, whereas the motor is mounted directly to the head here. And that's a modification. Like, these are the same printer, essentially. That's a modification that I was able to make by just 3D printing a bracket. So the printer printed a part for itself.
Nice.
And it was a modification I needed to make because I'm using a different material here. And the story behind that material is interesting as well. I actually have, one of my clients is a father of a young man who had an accident and lost his thumb. And so I've been 3D printing prosthetic thumbs for this guy. And I absolutely love doing that. And I was working with a design that they supplied me initially, but I'm now designing a more realistic looking thumb, so that it can pass more easily in public. I don't have anything worthy of showing off for that just yet, but I'm really looking forward to getting my teeth into that. That's not necessarily a great metaphor to use. But anyway, yeah, so the point is that you can tool around with and problem solve not only in the design and manufacturing of the item, but actually in the configuration of the machine itself. And you can make improvements. Another improvement I made on this one is this holder for the filament. I just got a couple of bearings, you know, those little hingy, not hinges, but axles, off eBay for a few cents, and printed a new holder for the filament, because with the soft material that I needed for the prosthetic thumb, it was necessary to weaken the way that the printer holds the material while it's feeding it into the print head. And once I did that, the resistance to rolling from just having the spool on a plastic bar, like on this printer, was too much and was holding the filament back when it was trying to feed it into the print head. And so I printed a new holder with those bearings on them to allow the filament roll to move more freely, and that solved the problem. And so, like, you get to just overcome obstacles with ingenuity, and not necessarily your own ingenuity. That was a design that I found online, but it was someone else who had solved that problem for themselves. And the community is happy to share these things freely amongst themselves. So that cost me nothing but the cost of the bearings and the cost of the filament.
Awesome. Since getting a 3D printer, have you started looking the world through the eyes of like, ooh, what else can I 3D print to replace? Yeah.
Oh, absolutely. That can get tiring though, because you end up with a massive list of things to print, and so you kind of reach a point where you just go, or you don't even consciously think of it. You just stop doing that, because your list gets too long and it gets a bit ridiculous. But one thing that it absolutely has done for me is I really, really appreciate what a tough job product designers have. And it's something as simple as like picking up a remote control and feeling the ergonomics of it and going, oh, and then you open the battery case and it's got supporting buttresses inside to keep the shape. Oh, and all of these little design features that I have had to kind of work back into in first principles. And there's lots of and functional stuff, like for example in this ship here, the buttons that I wired up to make those lights and sounds come on and off. I had to build a little caddy system for the buttons, because in order to be able to wire the buttons in, I couldn't have the contacts for them sandwiched down in the bottom of this trough here, because I wouldn't be able to get at them with the soldering iron.
Mm-hmm.
So that necessitated redesigning this and coming up with a way to have that slot in neatly. And there's all sorts of little clever solutions, I suppose. Well, they feel clever to me anyway. I think they probably are clever, but just unique ways of thinking about things that it prompts in you. And then you start to appreciate that in everything else that you see that has been designed, because we live in a very designed world, you know.
Yeah.
Everything we interact with on a daily basis, someone has thought about how's that going to be used, and will it hold up to the structural stresses that it's going to be under? Can I make this end of it look nice while still being strong? All of that kind of stuff.
Yeah, I understand that completely. Like a year or two ago, I started following this Instagram page called We Are Engineers, and there they show some of like large scale solutions that engineers are working on, but sometimes they show like really small scale, like slick solutions where somebody figured out to do something in a unique way that you wouldn't think it's possible. And once you see it, you're like, oh my God, this is amazing. Like the guy that thought of this, he's a genius, right? And then you're like, why is not everybody doing it exactly this way? And I love that effect. And I feel that it's obvious when you see it, but getting to that point might not be that obvious, right? You sometimes have to invest hours and hours of thinking, figuring out, trying, going back and forth. And that's the engineering side I feel that a lot of people have kind of like inside of them, which only gets
latent.
Latent, exactly. And projects like this can really wake this up in a person.
Yeah, and the satisfaction you get from engaging that side of yourself, I had no idea it was there. You know, just it like the little posts I was talking about, these little S-bend things. I have never seen anybody use that design before for this purpose. It just came to me when
hold the structure, right?
Yeah, so it's just two S shapes that just sit into one another, and it relies on them both being on posts, so there's a little bit of play, so that when they come together, they will knock over each other and then slot into place, and then they hold it together, and it feels solid.
Yeah.
And I just came up with that one day, and I printed a little test piece to see would it connect, and it did, and I was like, oh. Yes. Yeah.
Patented.
Coming up.
Patented.
Well, there you
Stop
go.
The podcast. Stop the podcast. Cut this part out.
Yeah, I'm just leaking IP everywhere at the moment.
Brendan, you're gonna make millions, like.
Or somebody else is gonna make millions on these ideas after watching the podcast. That's the concern.
An engineer in China is like, oh, S shape. That's what we were missing.
Yeah, but I mean, it was just like, you come up with this idea and you think, will that work? I've never seen that before. But if that works, surely someone else has done that. And then you try it out and it works, and it feels so good when it works. It's great.
Cool. Awesome. I feel that 3D printing allows people to kind of get that another dimension of their creativity to unfold itself, because they start from not hard mass, they start from like a program and basically a picture in 3D space on a computer, and there you don't have that many limitations, right? If you started with bolts and screws and pieces of metal, you might not even think about it because you couldn't bend the metal in a way that you wanted, and here you're in a program, you're like, oh yeah, let's just try this, right? And
can you would you be able to let me share my screen? I just want to show you the program I'm using.
That was one of the questions that I actually wanted to ask. What are some of the programs where you can actually make the designs?
Yeah, so any 3D package is good for this. There are ones that are built into Windows that I haven't really tried myself, but I'm sure are pretty good. I'm using this one, which is called Blender, and it's free. And it's actually it's been around for a very long time, and is chiefly used as a 3D animation package for like movies and TV. But I've been using this one simply because it's what I had when I started working on the 3D print stuff, and I had been using it for modding a game, making modifications to a computer game, and just because it was available to me, I started using this.
So for everyone listening to the podcast,
oh yeah,
Brendan is showing a 3D model of the ship that we mentioned earlier from Star Trek, and it's a picture underneath, and there's a 3D model on top of it. So you were designing the 3D model based on the picture underneath that you got online, right?
That's exactly right. So this picture is it's just there for my own reference. I have it lined up so that I can sort of turn the ship transparent and almost trace through it, but it's chiefly there as a reference piece. And this picture, I should credit it. It's to it's credited to an artist on DeviantArt called Farshot. And I remember many years ago, it was actually, this was put together as part of a game modification as well. And he was similarly obsessed with getting the studio model accurate shape of the Defiant. The name of the ship is the Defiant. And so I knew he had done that, and I thought, okay, I can stand on his shoulders as such. But I've actually found quite a number of things that he overlooked in his work there as well. Not knocking his work at all, because I have benefited greatly from it. But there's just a lot of smaller details that you might miss. And I'm in the midst of remodeling my ship because of more details that I've noticed now.
So and you can zoom in very much in this program, right? You can go into all the
So you can work on individual lines and skew them around. So zoom in tight on that line, and just like, if that's at the wrong angle, I can change that, you know, and do it down onto the nitty-gritty level of each facet, literal facet of the ship. And one of the things that really jazzed me at the beginning, or not so much at the beginning, in the middle of this project, I suppose, when I first printed the prototype that I have here, was the thought that this came from literally almost, well, I mean, literally nothing. You see, I'll change the window I'm sharing just so you can see some of my progress photos. How do I do that? Stop share.
No, it really looks amazing, and there's so many details. I understand why, if somebody was to make a toy out of this in traditional methods, they would have to leave out a lot of details out. But if you do it like this, where you can zoom in on all the details, you can really get a lot more authentic, you know, like a lot more authentic design. And I'm sure that for people who are collecting toys like that, or memorabilia, or generally figures, they really need the details to be on point, and I think it means a lot to them, right?
Yeah. Yes. There are limitations in how a toy has been traditionally manufactured, particularly if you're talking about, like, there's limitations in 3D printing as well, but you kind of work around them. And toy manufacturers down through the ages have been working around their limitations as well, but you still see them. For example, the ship I pointed to earlier, the commercially available one, or it was at one point commercially available, it's quite old now. It has screw holes. It has various artifacts of it being a traditionally manufactured item. And you can kind of get around those to a certain extent with 3D modeling. But the other factor is that that was made by the employee of a toy company who may not have been an obsessive Star Trek fan as much as I am, for example. In fact, I know that particular one, they borrowed the molds from another company that had also made a model kit of the ship and based their toy molds on those. And so that's a second generation copy of inaccurate reference to begin with. And that said, that was made back in the 90s. We live in a world where we're able to access a lot more of this kind of information. So I don't blame them really for getting it wrong at all. It's just because I'm an obsessive nerd, I need to
Yeah.
get it right. But I wanted to show you this these screenshots that I have here just to give you an idea. This is how the ship started. And this is actually a little bit after I started working on it, that I thought to take some screenshots and actually document what I'm doing.
Mhm.
But literally all it was to begin with was a cylinder. And I kind of snapped the lines that made up the cylinder in different places to pull them out into different 3D shapes, and started adding more detail to it, as you can see here, and a little bit more, and on until I was
Yeah. Now it
getting,
looks like a proper ship. Yeah. Yeah. Yeah.
yeah. So it kind of evolves as you work on it, and
Mhm.
then I endlessly tweaked it for months as well. But yeah, it was super. Like, I don't regard myself as a particularly talented 3D modeler, and so
Dude, this looks amazing.
thank you, I agree. And that's the point. Like, I don't regard myself as a great 3D modeler, but then I see what I created and how satisfied I am with it, and it just gives me such a thrill. It really does. Like, I cannot believe that. And this is what I was getting to, that after evolving the ship from a cylinder to this highly detailed replica of the Starship Defiant from Deep Space Nine, it was kind of stunning to me to see it emerge from the 3D printer and think, I handcrafted every polygon of that 3D model, and now it's emerging from the 3D printer.
Yeah, amazing.
And,
We'll definitely leave a link for everyone just listening on the podcast site to take a look at the pictures that Brendan designed. Some of them are like already with the background shaped into deep space, so it really looks like a real spaceship.
And once I had the exterior structure of it designed, I'm scrolling down for the sake of the listeners. I'm scrolling down through the album of photos. There are, or not photos, but screenshots. There are many pictures here that detail the design process, and I have captions on a lot of them describing what I was thinking as I was doing them. And so you get to see where I'm designing the stand, designing the interior, and thinking about having to route cables through it, how to house the microchips and so on that need to power the electronics. So there's an awful lot of detail on that particular project available in this album if you're interested in the thought processes behind it.
Amazing. Yeah,
but
each
what
part tells a story.
Yeah. And what I'm actually looking for as I scroll through it, yeah, here we go, is when I actually printed the prototype for the first time. And I have some photos. Yeah, here. So this is the stage where I had, given that this is a passion project, I'm working on it day by day, and I sort of am fueled by equal parts nerdiness and panic that I'm gonna get it wrong or I'm gonna screw it up in some way. And to try to push that panic down, I wasn't really checking as I went that I would be able to fit this thing on the printer. And sure enough, when I tried to set it up for a print, it was not going to fit. And so I had to modify it then. You remember I was holding it by the front end and saying that's a part that slots on, but I can hold it. Well, the reason that part slots on is because it would not fit in the print volume. And so I had to rejig the design of the ship and come up with a way for that to slot in. But a combination of fitting this large object into the print volume, which is about 23 centimeters by 23 centimeters by, I think, 30 something centimeters in height. A combination of needing to fit it in that volume and also finding the best way to take advantage of the angles that the printer can print at and the way that those surfaces then come out in terms of the fidelity of detail on those surfaces. I ended up printing it at this very odd angle. And you can see in this picture, if you're watching the YouTube version, that the ship is at about 45 degrees across the print bed. It's also tilted upwards at about, I don't know, 60 degrees. And it is supported by this almost organic looking network of what look like roots. And that's a support material that the printer prints as it prints the ship, so that this is another aspect that you kind of have to take into account when you're designing these things for printing. Gravity is going to take that hot plastic and pull it down. And so if you have unsupported parts of your model that will be subject to gravity, those are going to get distorted. And so you have various ways to support the model as it's being printed. And one of my favorites is what's called tree support, where the software that you use to translate your 3D model into those two-dimensional slices, now the software is called a slicer, that software can algorithmically grow a tree of support to support any part that may be subject to the whims of gravity. And so you get this very organic looking structure that comes out of it. And as the print went on, it was kind of thrilling to see. This is a good one here.
Yeah, it really looks like a root of a tree. I
Yeah.
personally didn't know about that. I thought that most people just print it like that and it stands. But yeah, when you get into designs like this, it won't work on its own.
Yeah, yeah. And so you need to be able to snap all of that off and clean up your model afterwards. But to me, this looks like, you know, the spaceship is emerging from some giant space plant that's trying to claw it back. and
How hard?
This is, sorry, go on.
Yeah, how hard is it to remove the roots of the plant from the actual design?
It's designed so that when, like, the software is designed to grow this tree so that it's reasonably solid to take the weight, but when it actually touches the model, it does it in little pinpricks so that you can snap those off fairly easily and then just wipe them clean.
Because I do have a feeling that there's like a small shadow on one of the roots there, so it's kind of a little bit separated, right?
This here?
No, a little bit further up here at the end of the root, or at the V crossing of the root.
Here?
A little bit, yeah, here and the lower part as well.
Oh, here, yeah. So it is standing out from the bottom of the ship there, because it doesn't need to support that area. That's a relatively flat area. And with the angle that the ship was sitting at 60 degrees, it can support itself as long as that section is flat and doesn't have any parts that stick out. But so it's building on top of itself as it goes up and up and up and up. But if you have any details that then stick out, which would be sort of sitting, because this is the bottom of the ship that we're looking at, this would be, you know, hull plates or hatches or anything that are proud of the surface, then that part at that angle might need to print separated from the hull to print like the leading corner of that. So it will grow a tree to just where it needs to be to support that leading corner, and then it will print inwards until it connects with the hull and then carry on. So
amazing.
It's clever software.
Yeah. I really didn't know that you need to use that, but now the more I think about it, I realize how necessary it actually is.
Yeah. So that's another thing, like in terms of the brass tacks and the cost of printing, you need to take into account that you're not just printing your model, you're also printing supports for your model, if they're necessary. Some models you can design to be self-supporting and you won't need to enable the support tree at all. But that support material, and particularly in this case where the ship has to print at such an odd angle to be at the scale that I designed it for, you need a lot of support material. So that's actually going to add material cost to your print. And that's material you're going to end up hopefully recycling. But for me at the moment, I don't have a method to recycle that into new filament. So it goes in the recycling bin. Okay. But yeah.
Can you give us a little bit of an insight into the filament cost? Like what kind of filaments are you using and how much does one of these rolls that you have on your 3D printer cost?
Yeah, so I generally get a kilogram of PLA. PLA is short for polylactide. And here's a refill here. So what I've been doing lately is I have reusable spools, and I get these refill rolls that I can just slot onto the spool. So, excuse me, that's a filament spool there. Sorry, that's a filament refill. And so this is the filament.
So that's basically thousands of layers of wires, right? Or hundreds, maybe.
Yeah, it's one continuous wire.
Yeah.
And it's just spiraled around.
Okay.
And I have these reusable spools here that I can open up and put this onto to reload. Initially, I was buying new spools every time. And so I ended up with stacks and stacks and stacks of these things.
Okay.
Which is a little annoying. So it ended up being more economical, but there's not a lot of companies producing those refills. So it seems like it's perhaps a good area for someone to expand into and try to compete with eSun, who are doing the refills. But in terms of cost, the refills cost between 17 and 25 euro for a kilogram of this material. The Defiant, that I can print one whole ship on 1 kilogram of material. I think there's maybe like 75 or 100 grams perhaps left over afterwards. So it is quite efficient in terms of the usage of material. And you get quite a lot of printed objects for a single kilogram. Some of the orders I've been filling for work, I needed to print 80 kit parts for a particular kit for the company that I'm contracting with, and that ended up consuming, I think it was 6 rolls of filament. So it was just over 100 euros worth of filament to do that. And then, you know, other costs like the cost of running the machine is fairly low, but you need to take that into account as well, electricity costs, and the maintenance time and all that sort of stuff. So I think I ended up charging, I think it was about 4 or 5 euro per part for that 80 piece order. No, does that make sense? That doesn't make sense. No, it does make sense. Yes, yeah, that's correct. Yeah, and you know, that included a bit of a profit margin for myself as well. So, but the customer was thrilled with it, and satisfaction all around. So it's awesome. Workable. You can make ends meet with it. Well, you can make ends meet on individual items, but it's down to how much time you want to spend working on this. Whether it can be ultimately profitable for you or not.
Exactly. I feel that if you dive deeper into a business like this, where let's say you print and ship out products for people that order them online, that you would need multiple printers.
Yeah. And the two printers that I have running are probably minimum requirement, because when I was going full tilt on the glut of pre-Christmas orders that I had, that was a case of running each printer simultaneously 24 hours a day, and like setting alarms to go and check on them,
wake up in the morning,
change the filament roll if it needs to be, all that kind of thing. And then of course the bugbear with 3D printing is that the printers are not maintenance free by any means. You need to keep an eye on things, make sure that there aren't any problems that need to be solved. Sometimes the filament might get twisted and wrap around on itself, and when it goes into the feeder it breaks, or sometimes the seal on the nozzle might give way and you suddenly get an outburst of filament that fills up the whole the whole casing of the print head, and then you have to go and kind of hack that out and figure out ways to get it through. So there's a lot of maintenance issues that will crop up, and there have been times that I've been tearing my hair out, but then once I hit upon the solution, it's another case of that kind of engineering satisfaction moment, you know. So yeah, it's rewarding in its own way.
So what do you do when I don't know, a design breaks, or sorry, something breaks in the printer and your design is suddenly halfway finished, something has gone wrong. Is there a way to kind of like pull the printer back in the design to restart from like 5% back, or do you
Yeah,
have to
there is
start all
actually.
over again?
The nose end here, you can see that line, that division there. That is not a detail on the model. That's actually an artifact of exactly what you're talking about. There was a part on the inside of the nose here where what I was talking about a moment ago, where there's a detail that maybe sits proud and the corner of that prints before the part that connects it to the rest of the model. That actually happened here. So this little box, which is for the nose that, or sorry, the light that lights up the nose section there, and that light plugs into the back of that box.
Okay.
And when that was printing, it was couched in support material, and I wasn't concerned about it. But what actually happened was that the print head just happened to knock the topmost layer when it was passing by it. And because the support material only touches it in kind of very gentle ways, it dislodged the part of this. Now I should point out that it was printing at this angle.
Yeah.
So those are the horizontal layer lines then. And so that edge in there was printing free of the rest of the structure, but was only supported in the support material. And when the print head struck it and dislodged it, it just shifted angle. And when the print head came back again, the now free section of that box got stuck between the print head and the rest of the model and made the print head jump. And then that happened on every subsequent pass. And so when I came back in the morning, it had printed at maybe another 50 or 60 layers since that had happened, but every single layer had been separated by that bump. And so you had this mess of filament just all over the room. And I was like, oh no. And I came up with a solution. Did I come up with this myself? No, I didn't. I found a YouTube video for someone who had this, not specifically this issue, but the issue of a print failing partway through and you want to rescue it. And what you actually do is, it's kind of delightfully low key. You open the print instruction file that you would load onto the printer in a text editor. You measure how high up the last good layer was in millimeters, and you find the closest vertical instruction in the print file to that height, and then you delete everything before that and you reload that file into the printer. So it goes directly to that height and resumes the print.
Yeah, slick. Yeah,
it's really slick, isn't it? And that's exactly what happened, and it carried on and finished. And it was printing the nose section and the body at the same time, and it was actually the nose I had to glue a bit because there was a little bit of separation there, but the body, yeah, I think I don't even know if it'll show up because it's so hard to see now, but the scar from that incident is actually here, but I really don't think it's visible.
Nope, can't see it.
Yeah, so
which is good.
Yeah, the scar is not really visible here at all. Now that fix will often solve the problem for you, but occasionally the sort of left and right and forward and back calibration of where the print head is over the print bed can get disturbed by whatever stopped the print. And so when you resume it from that height again, you can have a slight offset, which can ruin your print, or sometimes you can fix it by breaking at that point and re-gluing it. But most of the time, you will have a successful print, even with an issue like that.
Awesome. Those are some amazing stories that you told there, Brendan. I really like how your designs look like. We're definitely going to leave some photos there for people to see them. This actually reminds me of the last time when we were talking about 3D printing was in the Future of Foods episode. We kind of touched on it briefly, but I want to go through it again because it's very related to 3D printing at home. Well, it's not that close, but kind of the concept still stands. The 3D printed meat. Can you remind the audience and me a little bit? How does that work, and where are we with that? Are we gonna eat 3D printed burgers in the next year or this year?
3D printed burgers, I'm not too sure about. And it's sort of, there's, if you stretch the definition of a 3D printed burger, you could say we're already eating 3D printed burgers, because there are, of course, industrial processes that squeeze out some paste onto into a patty shape, and off it goes. But in terms of more complex foods, like I think 3D printing is going to play a part in what would you call it, the cruelty-free meat market. So when we get the technology of cruelty-free meat, by which I mean cultured meat, the kind of stuff where you take a biopsy from a living animal and you culture that to create meat that does not require the animal to have died. So you could call it ethical meat as well, I suppose. But anyway, the angle in that particular market for 3D printing is, of course, making the cut of meat that you sell in the supermarket actually resemble a cut that has been taken from a slaughtered animal. So that could involve maybe 3D printing a scaffold structure to support the meat as it is cultured, and bring it into shape, or indeed 3D printing strands of muscle fiber themselves. Now, I'm not aware anyway of any active manufacturing processes that use that, but there's certainly research taking place in that area. But of course, I was talking about some of the shortcomings and sort of handicaps that you get with the technology as it stands now. All of that, you then add, biological liquids to, and proteins that can set in certain shapes and so on and so forth. You're going to have an extra layer of complication there. So there's a lot more technical development to go into that before it could be practical. It may be a path for meat to take, but food in general, I think we'll see more 3D printing of food going on in resource constrained environments, like Arctic bases, submarines, it maybe even cruise ships, and of course
ships,
spacecraft.
probably.
Navy ships, yeah, quite possibly, yeah.
On long missions, if they're not there for months,
It really depends on whether that is more economical and more space efficient. Those are the things that are going to come into it, than having a full galley. And certainly on naval ships, they can squeeze a galley into an incredibly small space and still produce quality food for a lot of people. But yeah, as I say, it comes down to economics and space conservation. But I suppose that links in, as you say, it links in with our previous episode on the future of food, but it also links in with the future of humanity and space exploration, because not only can you 3D print the foodstuffs that people are going to need, you might be needing equipment in isolated locations, such as what I've talked about there, naval ships, bases in Antarctica or off-world, on the moon, on Mars, in deep space or in orbit. They've already taken 3D printers to the International Space Station to create equipment that they might be lacking. And so far it's been sort of experimental, in the sense of, like, does it work well? And can we produce stuff? There isn't the spontaneity for someone to go, oh, I need a wrench of this particular size, I'm going to go print it. It's sort of controlled and directed from the ground at the moment. But they are researching stuff like in zero gravity, for example, on the International Space Station. You can do protein growth for pharmaceutical purposes that you can't do on the ground, because the gravity of the Earth will break these protein chains as they're they're created. And similarly, you can do very fine detail 3D printing work in 0G. So there are a lot of applications that can be pioneered in 0G, and so I expect it to stick around in that arena. And I'm not sure what we're going to see, but we're going to see some interesting stuff, not least spacecraft potentially being printed from raw materials mined from asteroids. That would be really cool.
Yeah. It sounds like a great idea. The only thing that comes to mind is like the materials that we're using here on Earth kind of seem like plastic-like, where they're easy to melt. I can't imagine materials on an asteroid being plastic-like, you know, like what would, like, I imagine it as a bunch of rocks. So what would keep the mass together, you know, like it feels like it would just start to crumble or evaporate or scatter in space.
I mean, pretty much anything that you can melt, you can 3D print with. So you can melt sand into glass, you can melt rock into molten rock and then re-solidify it, and you can also melt metals. And a lot of asteroids are actually, some of them are primarily composed of metals. There's an asteroid, or sorry, there's a mission to an asteroid called 16 Psyche that's underway at the moment, and that asteroid is thought to be, in some circles, I think there's some debate over it, but it's thought to be potentially the core of a failed planet, a planet that was accreting in the early solar system, just like all of the rest of the planets, and our own Earth was accreting from the material that was swirling around the sun. And it got to the stage where the gravitational forces were compressing it enough that it went molten. The heavy stuff fell to the center, and then just by chance it happened to smash into one of the other planetesimals that were accreting, and all of the crust and outer core got blown off, and all that's left is this big, I think it's like 200 kilometers across, hunk of solid metal, because it re-solidified at that point. And so there's a mission heading out there, and that would be really interesting to see what it finds, because so far this thing is just a dot of light in the telescopes, and we've done spectrography, yeah. Sorry, where you split up the light and understand what chemical elements are in it, and it's just like all metals. So that's an extreme example, but there are a lot of asteroids out there that have high metal content in them. And it's an interesting kind of distinction to have to make, because for an astronomer, a metal is anything that isn't hydrogen or helium. Like literally everything, like your skin is a metal according to an astronomer. Okay. But that's just, I'm not even sure why they talk in those terms, but I'm talking like in the everyday terms, that these asteroids are made of metals like iron and nickel and I don't know, cobalt, cadmium, all that kind of stuff. Part of the reason that rare materials on Earth are rare is because of that gravitational sorting when the Earth was molten, that the heavy stuff literally just sunk down into lower layers, and so it's very difficult to access for us.
So it's actually not rare, it's just like far away.
Exactly, yeah. There's layers below. Exactly, there are layers of gold in deep, inaccessible layers of the Earth, far deeper than we could ever drill to. And they might as well not be there as far as our economics are concerned. But out in space, where when everything was swirling around the sun and coalescing into the various planets that we have now, it was a violent situation. So there are lots of asteroids out there that are fairly evenly mixed in terms of the elemental composition, and you don't need to dig far to find valuable stuff. I think someone said 16 Psyche, if you were to lock the value of gold, that 16 Psyche likely has enough gold to give every person on Earth $350 million worth of gold. That all, what is it, 7 billion of us?
Yeah.
So that's crazy. And of course, if you did do that, it would completely devalue gold, and none of us would be any better off, really. But the point being that you can melt gold, you can melt metals, you can melt rock, and that's all a 3D printer is. It's a moving head that melts your feed material. There are already metal 3D printers in action on Earth. There's a company called Relativity Space that's actually printing an entire rocket from metal.
Whoa.
Oh, it's super cool. Yeah, you can see some of their time lapses of the rockets printing, and they have some really, really, really cool plans for the future. I don't think they have yet launched. Did their
Probably
Terran 1
not.
rocket actually launch?
It'll probably be in the news. We probably would have known about that, right?
Yeah, they're building a smallish rocket called Terran 1, and I think it was taken out to the launch pad and they did like a static fire on it, but it's a working rocket. Like, they didn't have a failure anyway. I know that much. But yeah, I think they're going to launch soon. Anyway, they're also looking at building a bigger rocket further down the road, and that's really cool. It's all going to be all 3D printed. SpaceX 3D prints parts of their rocket engines. Rocket Lab 3D prints their engines. All of this is done in metal, and the way that the 3D printer actually prints that metal is quite cool. They have two laser beams that cross at a point in 3D space, and at that point the temperature of the crossed laser beams is high enough to melt metal, and they blow in a dust of metal from two sides, and it just crosses into, and any that happens to cross into that laser beam gets melted and and deposited then on the growing item.
And the rest, it just gets circulated back.
Exactly. Yeah, it gets sucked back out and blown around again, and so it's really cool to see it happening, because it's almost like it's just a haze and the thing is appearing from nowhere.
Yeah, out of nowhere. Yeah, awesome. But that requires a closed system, right? You couldn't do that.
Absolutely.
Yeah.
There are the powder plastic printing that I was referring to earlier, where you can like order I keep forgetting the name of the company that's most famous for doing that, but like you can take photographs of people, and if you take them from a couple of different angles, you can send it off, and they'll like interpolate the 3D model and send you a model of that person, a statue of that person, complete with the color printing on it.
That's like a cool
They
gift.
do that. Yeah, it is. I wish I could remember the name of the company, but anyway, they do that in a similar way, but with plastic dust, and it's I think it's like I think it is a laser. Yeah, it is a laser, because they vary then the strength of the laser or something to get the colors in the material.
Yeah.
But in any case, this is one of the other methods for 3D printing, and this one applies very well for metal. And it might be, I don't know, would they be? Yeah, it probably would be the more practical way to do 3D printing in space with pulverized asteroid. So you can take stone, or pulverize, for that matter, you could lift the lunar regolith off the surface, which is very powdery already, and just blow that through your laser focus area and build something out of lunar regolith.
Nice.
There's already plans. Sorry, go on.
Yeah, no, finish. I just wanted to say that it sounds amazing.
There's already plans for building habitats on the moon using lunar regolith that you just suck up and run down some kind of tube. And there was a really weird article recently about, because one of the issues with that is like, where do we get the lubrication to run this stuff down the tube? And a bunch of researchers looked into like astronauts donating blood and using the blood as the binding agent in the regolith. It's like, where did you get this idea, and why is that the best solution? So yeah.
All right, let's think about that for a second. You actually constantly create new blood cells, right? So
yeah, but not by magic. You need to feed yourself.
Yeah, well, you do that anyway, right?
Indeed.
If somebody takes but then again, I presume to build anything of structure, size, or mass, you would need a massive amount of, like some lubricating mass to kind of make it work. so that wouldn't work. And as far as I understood, for all the missions that they're planning, they're not planning to send people first there. They're planning to send robots and self-assembling structures that are going to kind of build themselves out over time, right? And
that is the nominal concept. Yeah. It remains to be seen whether we can. Well, I mean, I say it remains to be seen, but I think we're demonstrating all the time that we can do remote work on foreign space bodies through the likes of the rovers on Mars or the Chinese rovers on the moon at the moment. None of them have done any direct 3D printing, so that would be interesting to see, because there's a lot of mechanical stuff. As I was saying, there's like a lot of maintenance to keep these things going.
Yeah. So what would we need? Robots that have human-like hands that someone could like with 3D glasses kind of like work on it directly.
But the problem there then is that telepresence is difficult unless you're in orbit of the planet that you're doing it on. So for example, if you were trying to operate a rover on Mars, or a robot on Mars, I should say, you've got at least a 3-minute one-way light travel, up to potentially 10 to 15 minutes of one-way light travel. And then to see whether it's actually worked, you got the same time again for the bounce back.
The most horrible lag in gaming history.
Entirely, yeah. So you would need to be in orbit in a spacecraft doing that kind of telepresence stuff. So that's, reliability is going to be a question on these kinds of things. But even if it does require people to be on site, with the kind of spacecraft that we're looking at now, we could be sending a spacecraft that just lands there and you live in the spacecraft. Like, for example, I'm thinking of SpaceX's Starship. That's a huge volume to live in anyway. So the benefit of building the surface habitats is that you get better radiation protection and you don't need to fly back in them. Like they're going to need the spaceship back, so it's going to have to fly home at some point. So you build yourself a habitat on the surface. And there's already pilot programs for that kind of large-scale 3D printing for constructing habitats happening all over the world, actually. I was going to say in Africa, but that's just the initial pilot programs were there, where they would take local materials from the ground, run it through some kind of cement mixer style thing, and they had a massively scaled up 3D printer that was just spudging out the cement into the shape required to build a house. But there was a video that hit the internet there middle of last year, I think, from China, where there's a company that is literally building mansions just by 3D printing them. Very impressive stuff. And then there was a NASA sponsored Martian habitat competition, and the winner of that was a 3D printing system that was taking the simulated Martian regolith that they were giving. Sorry, I should explain. Regolith just means soil. It's just Earth without the organic element that we have on Earth. But so just the
dry Earth.
Yeah, exactly. And they were giving the teams like a dump truck full of this soil and going work with that. And
do it.
Yeah, exactly. So these guys printed this structure that was like a barrel shaped tower, and they would ship up some small plant in windows and stuff and doors, but print everything else, and then like inflate a airproof or a atmosphere sealed bladder inside that structure then, so the printed structure provides strength, and the air seal is provided by this bladder that they inflate inside. And it was reasonably successful. I seem to remember right at the end of the competition, they leaned a digger on the top of this thing to test its strength, and it did collapse, but they still won the competition. And it was like a quarter scale version, so I would imagine under lower Martian gravity, etc., it'd probably be okay.
I've seen some simulations of how drones are building out habitats on Mars. It looks really futuristic and cool. Flying and little driving drones, and structures they would build wouldn't be exactly the same as the ones on Earth, right? We would have like cubicle shaped houses, but what I've seen them build is more like sphere shaped, more like dome shaped objects.
Yeah. A lot of that is down to just the physics of holding in the atmospheric pressure that you need for people and Earth life to survive in, because the atmospheric pressure on Mars is under 1% of that of Earth. It's practically a vacuum. And so you need to contain the pressure that we're used to living in within these buildings. And the best vessel for containing pressure is a sphere.
Yeah, so that's why.
Yeah, that's why you tend to get cylindrical or spheroid structures. Another reason that, for example, I was just thinking of the International Space Station as an example of the sort of shapes of structures you might see. But actually, the main constraint on the shape of structures going to the International Space Station is that they need to fit within a rocket's fairing, and that's typically cylindrical and long. So that's why those are that shape.
Cool. No, you shed some light there. I really think 3D printing in space sounds super cool. I didn't know about this 2 lasers crossing and the dust, or that also sounds amazing. And 3D printing rockets also sounds really cool. So I'm sure we'll see some amazing results that people are going to do in the next few years. Hopefully that makes this whole space race a little bit faster, you know?
Well, yeah. The actual printing of the rockets takes like a month or 2 because, you know, it's a large structure and 3D printing is relatively slow. But compared to actually preparing each individual component and then assembling it over time, it is, I think, faster overall, and it's much cheaper. So the main benefit, I think, is probably in terms of costs. But I would also argue that the space race is incredibly exciting at the moment. Anyway,
No. I'm not saying it's not. I'm just saying that it could be even more exciting if we see how fast something can get. What I'm thinking of is in the direction of you know how the first car took forever to be made, right? And then after a while, we managed to conveyor belt it and just make thousands of cars at the same time. I'm thinking of what happens when we can streamline produce rocket ships like that, right? That will be amazing.
That will be. Relativity Space is definitely a company to keep an eye on from that point of view.
Quick question there that just popped to mind. 3D printing rockets versus conveyor belt manufacturing them, as in like cars. Is there like a calculation which one is faster, more profitable, harder?
Well, that remains to be seen. I don't have a direct answer for that, but I do
gut feeling. Go with gut feeling.
Gut feeling. I don't know. I think it's probably faster to hand assemble them, to be honest with you. As gung-ho as I am about 3D printing for a lot of applications, gut feeling is that maybe it's faster to hand assemble them. And my main point of evidence for that is just watching what's happening with SpaceX in Texas these days, putting together starships. Like, they have been hobbled a little bit lately by paperwork. They're waiting on FAA clearance to do more test flights. But even though there's nothing really sexy happening there in terms of like rockets taking off and exploding and stuff at the moment, what is happening is an insane production rate. They've been pumping out starships and like going from metal being unrolled off a spool to standing a rocket on a test stand in like 6 weeks, which is mad. Well, I should say standing a spacecraft on a test stand. They don't necessarily build the full booster, but similar time frame for the boosters as well. So, and that's only getting faster. Like, their aim at the moment is just to practice that assembly line technique, and iron out all of the kinks while also iterating on the design of the rocket. So like everything is a moving target for them at the moment. Even the design of the launch pad and everything is changing from day to day. And to see the pace that they are innovating at out there is incredible. And if you just search for SpaceX Texas or SpaceX Boca Chica is the name of the area, or Starbase, which is what they call their facility there now, you will find a cottage industry of nerds who have set up cameras in the area, and just through the practice of the last 24 months of watching what's happening there, have all of them become like actually really good news organizations
Nice.
with like multiple cameras and commentators and guests coming
YouTubers,
on and stuff.
streamers.
Yeah, yeah, and they're making a packet. I can tell you, watch any of their live streams and just watch all of the super chats
Super
coming in.
chat.
It's
Yeah.
insane.
Yeah, amazing. Yeah, it's super interesting. Like it's not every day that you see a rocket flying into space. Well, in a few years we might see them going up and down all the time, but
Yeah.
we're not there yet, right?
But that's I suppose to bring it back to 3D printing. The the Starship is experimenting or is testing, I suppose, to see whether assembly line production is faster, and then Relativity Space are coming out with their new rocket called Terran R in a few years' time, which is roughly Starship scale, and it looks kind of like a sexier version of Starship. It's got a lot more curves and more organic shapes to it.
More
And it looks
pointy.
really the top needs to be pointed. Yeah, so that will be a 3D printed, essentially a 3D printed answer to the same question that Starship is an answer to. So that'll be really cool to see them, how they stack up. Can Terran Ore be produced cheaper, faster, and sexier than Starship? That'd be really cool to see.
Awesome. Yeah. I like how you explained this, Brendan. Take us a little bit back though. Like most people are, I'm sure that most people listening who are not into topics like this are like, I'm not going to be on a rocket. I'm not going to be on Mars. I don't care about that. I'm here on Earth, right? What if a car hits me and I lose a leg or a kidney or something like that, And we mentioned before the podcast that there is one technology related to 3D printing that can also answer something like that. 3D printed organs are, something that some people say it's impossible, but tell us a little, educate us, Brendan.
Well, it's sort of, I mean, it's pretty much exactly the same problem as 3D printing meat, because that's literally what it is. You're printing meat with a purpose aside from sustenance.
And eating it,
yeah. So sustaining yourself by eating it. But so it's I wish I was more up on this, to be honest with you. Have you heard of any successful organ printing studies? Yeah.
I've seen videos where they're trying to print out a human heart, but I don't think they managed to print it out fully just out of meat. I think they're
I've
combining
seen the one you're
it.
talking about, and they like run electrical impulses through it, and it starts twitching on the petri dish. Yeah,
and I've seen one where they still have metal parts inside, or it's plastic or some. It's not biomass. It's help me out here.
a scaffold.
Yes, and it's kind of holding it in place or replacing parts that they still can't get to work. So as far as my like not that intensive research has found out, is that we're still not there, but
no, we're not,
but people are working on it, and it's a technology that's coming. And
talking about the scaffold as well makes me think of, like, we discussed it during the printing meat discussion, but it's, again, like, it's literally the same thing. It's the same problem, because when you're printing meat, if you want to achieve as much authenticity as you possibly can, then you want to grow the meat in the same way that it would have grown inside an animal. And one of the issues with that is that, as anybody who has watched a baby grow up into a child will be able to see, there are parts of the animal or parts of a living creature, you don't want to think of humans as animals, but spoiler, we are animals.
To a certain degree.
We're animals. There are parts of any animal or living creature that sort of expand and unfurl and grow. It's hard to describe.
Just like a tree out of an acorn.
Yeah, in a sense, but I'm thinking more specific. Like, if you think about a baby's ear, and then think about that person's ear 15 years later, it will have expanded and changed shape and all of that, but that's still the same ear. It's still the same tissue. There's been cells added to it, but what I'm getting at is that there are structures within the body, typically made of cartilage, that will be formed at birth, or at conception, I suppose, formed during gestation. There we go. That are, and I'm skirting around the word designed because it's not a design, it's an evolutionary design, if you will, that have evolved to unfurl in a particular way that is advantageous. And all of that kind of came together by accident. It was an accidental advantage in evolutionary terms. But the point of it is that those changes and unfurling of the support structures around the meat apply different stresses and compressions and thermal loads and all sorts of different environmental cues onto the actual cellular structure of that meat. And those are what give us differences in texture between, back bacon and pork belly, for example. But it also is what gives you the difference between a heart muscle and a tongue,
Yeah.
So you've got, there's also genetic information that gives those differences, and those we can account for as well with choosing what we biopsy and culturing stem cells into different expressions of the genes that they contain. So it's very complex, but the point that I'm getting to is that there have been computer programs developed now that have been able to reverse engineer, for example, the ear growth formula. And so it can instruct a 3D printer to print in this, and I've seen they have printed cartilage. So that's one of the stepping stones to getting this kind of authentic feeling meat that has lived, in a sense, the life that it needs to, without actually being attached to a conscious being. That can print it out in this kind of crumpled form. And then as you supply nutrients and electrical impulses and all of the experiences of life to it, it will, by its very nature, unfurl and provide the stresses and the environmental cues that this particular part of the body needs to have to form correctly. And so that obviously applies to creating authentic meat, but authentic meat is another way of saying a realistic organ or a realistic body part.
Yeah.
And so it's really interesting and really complex, but these are problems that are being worked on in tandem, and they're probably all going to flow together and create some really incredible stuff in the future.
Yeah. Another technology that comes to mind is stem cell research. I see it's very closely connected to 3D printing.
Bioprinting anyway, yeah.
In some regards, but also an amazing technology to look out for. We should actually do some research on stem cells. I heard athletes started using them, for example, ingesting them into, I don't know, you're playing basketball, your knees get weaker throughout the next 10 years, right? So with steady stem cell injections into your knees, with literally like an injection, where it's like a jello shot or similar like that, you can keep your knees in better shape for a longer time. Now, it's not everyday treatment that anybody can go to your local doctors and be like, hey, I want some stem cell research.
I get the impression as well that it's probably a bit of a shot in the dark. I mean, a lot of medicine is kind of a shot in the dark. When I think of the phrase shot in the dark, I think of like cancer treatments where they're just bombarding you with a chemical to hopefully kill the tumor that's in a part of you. But in the sense of stem cells are like programmable flesh, in a sense, that like you take a stem cell and you give it a certain stimulus and it'll develop into a lung cell, or it'll develop into a liver cell, or it'll develop into a bone cell. And so the just by, and I don't know this for certain, but just by the nature of living organisms, it's a very chaotic kind of organization that we have. Like our DNA code is like 3.5 million base pairs long. I'm plucking that number out of the ether. It's probably completely wrong, but it's millions and
billions and billions and
billions and billions. The information content of that could probably be quite readily compressed down to a shorter sequence. But we don't have the understanding of the complexities of how those instructions are interpreted to be able to safely compress that information down without losing something that may prove essential or may prove detrimental later in life. And it's probably the same story to a probably less complex degree with stem cells. Like, what kind of stimulus will provide the right kind of cell that we need to heal these knees. Now, the nice thing about injecting them into the human body is that they're probably going into the environment that will stimulate them in the right way to develop as needed. So that's handy, I suppose. But it does smack a little bit of, like, you know, Marie Curie drinking radium because it was beneficial for one thing, and then she's radioactive in her grave for 1,000 years.
Yeah, tricky. Also, how do you teach a cell to stop growing? You know, what if you?
Well, if you answer that question, you've cured cancer.
Yeah, right. And how do you program stem cell? You know, like there's so many questions that we have there, so it's still new, but definitely something to look out for. And we'll definitely do. We promise to the Young Goal podcast audience that we will do our due diligence research and do a stem cell episode deep dive in the future. I don't think it's the right time for it yet. We're
certainly not right now.
Yeah, definitely. We're trying to focus here on 3D printing, and still both interesting topics, but let's get back on track there. So,
well, it just shows you how integral 3D printing is to the future of technology, that all of these other fields get subsumed into it, and everything weaves together in unpredictable ways through the development of technology. And it's only natural that we get sidetracked onto these topics.
Yeah, of course. And they're super interesting. I always think of, you know, like futuristic films or TV shows that kind of spark the imagination there. And I'm thinking like cloning, you know, and I don't know if you watched Altered Carbon, but changing sleeves and things like that. So super interesting topics. And most people believe that they're super far away. I personally think that they're closer than we think. Just like it's usually the case with technology, you know. People thought the internet would take 30 years to fully develop, and it didn't.
But absolutely nobody saw how we would use the internet and how the internet would shape our culture.
Yeah.
I keep on bringing up the analogy of in Star Trek, you know, someone asks the computer, "Where is Captain Picard?" And the computer says he's on deck 12. Great. That's brilliant, so convenient, so wonderful, but nobody ever thought about, like, what's the corporation that made the computer going to do with that information? Which is our issue now.
Yeah, hopefully we'll solve that somehow. I'm planning to do a with you, because you asked that in one of the podcasts, a blockchain deep dive. I think there's a slick solution that could be done there with like zero proof technology and sharing but not sharing your data, but let's leave that for another episode. I think that might be interesting as well.
I foresee that one will involve me going, but what does that mean, repeatedly?
Yeah, and me going a lot, I'm not sure, but this is what I watched in the YouTube video.
Well, hey, you're gonna give away the whole how the sausage is made here.
Spoiling it now. Well, the audience has something to look forward to in 2022. We have a lot of episodes planned, but we still have to finish this one. So I also wanted to say, like, all right, we touched on a few 3D printing technologies that are far away. We touched on one at the start of the episode where it's behind your back, right? And you can use it every day to create objects for a hobby or a business. And I wanted to talk about a cool and fun version of 3D printing that I've actually tried in the last year, which are 3D pens.
Okay, I haven't tried this. This would be interesting.
Yeah, I visited a friend. He has a small kid, and they bought him a bunch of different toys. One of them was this 3D printing pen. So it basically does the same thing as a 3D printer. It melts plastic, and the fun thing is that you can literally draw shapes in mid-air, and it looks like magic, right? Because you have to move your hand slow, right? You can't go zik, 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 you know, like a magic wand. But if you move the pen slowly, it can literally stay in air, right? probably the first one won't. But if you connect it to like a cube shaped object, you can literally create a cube. After 10 seconds it gets dry, and you lift it up and you have like a cube in front of you. Super
Nice.
fun.
And what kind of stuff did you do?
So it's a small kid, so he was drawing like a flower, a house, and wasn't very skilled at the 3D element of keeping structures from falling apart, you know. And then I gave it a try and tried to do it a little bit more precisely. I managed to get a cube. It wasn't very solid, so you would have to take a lot of time to kind of fill it out to make it more solid. But for the kids fun element where they kind of, you know, like get a few lines to, you know, like stand like that and make a flower and things like that, it's really fun. It really works.
It makes me think of a VR program that I've used called here's me forgetting a thing again, but it was a painting program, but it was in 3D, so you get into VR and you can paint in midair, and artists have taken that and run with it and created some incredible stuff. So I wonder, like, put that pen in the hand of an artist who understands how to support the material, you could probably like end up with beautiful work.
Sure. Yeah. I feel that commercials that you see on YouTube and online seem a little bit over promising, you know, like people doing an amazing shape on the first try. You know, it's
Sure.
You probably won't get it on the first try. You'll probably have to do it like 50 times until you kind of get a feel for it, you know. And I think you have to have some kind of construct in mind, like how is it going to, you know, like stick to each other, and is it going to fall to one side? Is it stable enough? I think you need to take these kind of things into consideration. But I think as an educational tool for kids, teaching some engineering principles from the start, I think it's amazing. Like, imagine if you took like 10 of these pens, brought it to kids in preschools, and give them like an optional engineering class, you know, where they just get 3D pens and like, all right, today we're starting with a house, right? And then scale it up and teach them more and more. And as they're trying to draw something, you explain the mechanics behind, you know, I don't know, statics of a house, or gravity working on it, you know, like concept like that can be very challenging, but also very easy to understand if you have the right visual representation in front of you. You know, I just think that it might be a great tool.
Yeah, structural basics, I suppose, we what you're talking about. And I'm thinking about it there as you're describing it, and like, yeah, if you're essentially, what you're doing is taking the print head of a printer off the motors and doing a freehand, and it's going to be painstaking because you really do need to go quite slowly, unless you're doing like a line on a supported surface. But yeah, I kind of dismissed them because I was like, why would you want one of them? You'd need to do all of the shapes yourself. But I actually would like to try when they described it.
As far as I get it, they're not too expensive. But the first flaw that you noticed is that a fixed 3D printer, like you have behind you, has a fixed pace of applying an equal amount of mass or filament to a surface, right? Or to an object. Here, you kind of move your hand a little bit faster, and then it's like very thin. And then, of course, you're a perfectionist. You want to fix it. You go back. And of course, you can't hit it in a millimeter. That's like a gap, and one part is thick, the other one is thin, you know, and then you're like, you get angry about it, you know. So it definitely requires you to be patient about it and try to think as a 3D printer, like, all right, slowly draw the line, try to make it as straight as possible, you know, and then let it cool off. Just imagining
you taking that literally, like thinking as a 3D printer, you print out the instruction file from the printer and like reading it. Okay, over 5 mil, forward 3.
You don't need it because, as we said at the start of this podcast, the beauty is that you start with the design in your head, right? So you have all of this, which you have to kind of teach the computer how to understand physical reality and distance and all of that. You can understand that intuitively, like, all right, this needs to be this big, right? And you just draw it. So
and I bet with relatively little trial and error with one of those pens, you could start producing really, really intriguing stuff.
Sure. Yeah. I tried it for like 20 minutes, so I didn't have that much experience with it. The kid kind of started playing with it and we started talking about something else. So,
But I
don't
can't
know, man.
imagine it really escaping the realms of artistic expression. Like, you're not going to be making anything particularly practical with that, I don't think.
Yeah.
Not by hand.
Nope. Mhm. The closest to it what I see is VR. It's just superior form, because you can, like, let's say you're a teacher in school. You want to show, demonstrate, explain, draw, write something, right? So other people understand you. If you use a 3D printing pen, what do you do when you're done with the lecture? You literally have to throw the stuff out, whatever you're doing, right? And it's just, you can't reuse it because you lose the magic of creating it, right?
Yeah.
So it's the whole books and cutting down trees problem again. Like, you're infinitely repeating and reusing material, right? In VR, you're just like, delete picture, like new canvas, right? And the room clears itself out, right? And then you can draw from nothing again and create a new design. So
that's a whole other podcast, though. The VR, AR future that we're running
Brendan,
into.
We're giving too many spoilers out for 2022.
I know.
If you haven't yet, guys, you definitely have to hit the subscribe button on the YouTube channel of the Uncle Go podcast, because so many cool topics are coming in this year. Me and Brendan are very excited about this. I think we're gonna keep this technology corner as a regular thing now, and bring you, every once in a while, a cool new topic like that. Brendan, tell the listeners what you're pointing at.
Oh, I'm sorry. I was just suggesting that if there was anything shaped like a balled up fist with the thumb sticking up, that should be poked.
Of course,
regularly. With the pointing implement of your choice, be that a fingertip or a mouse click. Yeah, I like that button.
Slick, subtle.
Thank you.
So yeah, we made a lot of promises there for 2022. I hope you guys stay tuned. But before we go, Brendan, can you remind us the project that you're working on right now? What's it called, and where can people find more information about it if they want to look up some products or even buy some?
Sure. Yeah. The company that I'm working with at the moment is called MakerMeet.ie. They're pretty cool STEAM education outreach kind of stuff. If you're looking for fun gifts for a young person in your life who needs a little bit of engineering inspiration, perhaps, check out MakerMeet.ie and you'll probably see some of my products on there.
Awesome. And if people want to follow you for more of your content, where can they find you there?
Oh, I wouldn't recommend they do that. My only real social engagement at the moment is through Twitter. So I'm Destructor111 on Twitter if you want to see me rant about Star Trek, perhaps.
Perfect. And comment on Elon Musk's posts.
Indeed, yeah. Star Trek and the current space race are my two, and probably The Expanse as well. Science fiction in general, and science reality.
Awesome. Well, thanks everyone for watching. This was another awesome episode of the Uncle Go podcast. We'll see you in the next one. Bye-bye. The Uncle Go podcast.